Many studies on vulnerability have been focused on natural hazards rather than sustained climate variability and changes. In this study, a vulnerability assessment is performed in Nepal by considering gradual changes in temperature, precipitation, and extreme climate events.
Hi, I'm Benita Kisi. I'm a graduate student in University of Georgia. I'm a team lead of this project.
Hi, I'm Tiffany Webb. I'm an Earth System Science undergraduate at the University of Alabama in Huntsville.
I'm Ellen Cook, and I'm also an undergraduate at UAH in Earth System Science.
I'm Travis Burrell, and I'm also an undergraduate in Earth System Science here at UAH.
Hi, I'm Elisa Shrestha, Geomatics Engineering graduate from Kathmandu University, Nepal.
Hi, I'm Lakshmi Thapa, Geomatics Engineer from Kathmandu University, Nepal.
Hi, I'm Florencia Bandatlada. I'm a graduate of Geomatics Engineering from Kathmandu University, Nepal.
राम कलाकारकी हो म
तपाईको बसोबास
चाहिँ धापाखेल 2 नम्बर वडामा बस्छु म
हजुर
छैन सुकिसक्यो बारीनाली हुँदैन खेतमा लागिरहेको त्यो अब अहिले यो मुला आलुहरू चाहिँ पानी नपाएर चाहिँ सुकिरहेछ अनि धेरै लगानी अब खेर गइरहेको छ
प्रभाव त परिरहेछ नि अब टाइममा पानी नपरिसकेपछि त अब अन्नबाली उब्जँदैन खेत टेसिन्छ अब 100% त्यो उब्जाउ हुने ठाउँमा पनि 50% भइरहेछ हामीले अब हाम्रो इन्कम नै भइरहेको छैन हैन अब अन्न बाली पर्याप्त मात्रामा टिके नफल्ने बित्तिकै हामीले किन्नुपर्ने हुन्छ अरू ठाउँबाट इम्पोर्ट गर्नुपर्ने.
This is our overall methodology. First, we identified urban and rural districts, and after that, we weighted the mean change in temperature and precipitation accordingly.
We also included socioeconomic variables under sensitivity and adaptive capacity, as well as geographical vulnerability. Our total vulnerability was measured as a function of sensitivity, adaptive capacity, and exposure.
This research is important as it has quantified the vulnerability posed by climate change derived from the combination of biophysical and social data.
If we look at a GL-DAS image at 0.5 degrees resolution, we can see the lower temperatures in the Himalaya region of Nepal and the higher temperatures in the Terai region. As we look at an image from TRIM during the month of July, we can see the effects of the monsoon season on the country, showing high values of accumulated precipitation in millimeters per month.
There are 282 meteorological stations distributed across Nepal. The map shows the spatial distribution of the weather stations as collected from Department of Hydrology and Meteorology.
There are different types of disasters that occur in Nepal. For the vulnerability index, exposure is measured in terms of variables like drought, heat wave, snowstorm, flood, landslide, cold wave, hailstorm. And they were mapped as a climate disaster map according to the number of the events that occurred in the duration of 2000 to 2009.
We collected statistical data of various socioeconomic variables for the census 2001 from the website of Central Bureau of Statistics Nepal. Only those variables which have higher impacts of climate change were chosen, and these variables were then categorized into human sensitivity and adaptive capacity. And in human sensitivity, the variables like population density, household size were taken, and in case of adaptive capacity, the variables like educational level, number of technology users, and rural and urban areas were included. And these maps were then arranged and mapped in ArcGIS.
From 2000 to 2009, the hazard frequency was found highest in the Middle Hilly region and in the western part of the country, where the landslides occur.
The Social Vulnerability Index, or SVI, in 2001 showed the most vulnerable districts to be located in the southern area where population density is high. The Climate Change Exposure Index for 2000 to 2009 showed varying degrees of exposure, where high exposure areas include western, middle, hilly, and mountain districts. The overall vulnerability index for 2000 to 2009 included exposure, sensitivity, adaptive capacity, and place-based hazard. With this mapped index, we are better able to identify the most and least vulnerable areas of Nepal.
The resultant maps could guide policymakers to identify, prioritize, and allocate resources to develop a robust integrated approach to increase resilience to climate risk.
It's a great pleasure to be able to be sitting here in the Servier lab surrounded by developed students and to see that the partnership between Develop and Servier is really starting to create results.
I'm the capacity building lead in ECMOD for the Servier Himalaya project in Nepal. And I'm very happy with this partnership with Develop, NASA, and we are very happy to help students to work here as interns and learn about applied science projects.